There are many obstacles that can block the path to a successful software project. When you come across one, it helps to think like a seasoned hiker and follow the trail marked by blue blazes around the problem so that you can get back on course and keep moving forward. Welcome to Blue Blazes Podcast. I'm your host for the journey, Jay Tower, and I'm a partner and principal consultant at Trailhead Technology Partners. In this series, we talk with industry experts who share their best tips for avoiding the pitfalls on the path to successful software projects. My guest for this episode is Jesse Liberty. Jesse is a well-known expert in C#, Xamarin Forms, and .NET MAUI, and winner of both the Xamarin MVP and Microsoft MVP awards. He's a prolific author of programming books, including his recent title, .NET MAUI for C# developers. You've most likely heard him on his own podcast entitled Yet Another Podcast, or on one of the numerous online courses on platforms such as Pluralsight, LinkedIn Learning, Udemy, or Pact. With such a distinguished guest, you know it's going to be a great conversation, and our conversation today is about the very important topic of unit testing, so I'm very excited to share it with you. Let's jump in. Hello, Jesse, and welcome to the podcast.
Hi, Jay. It's been forever. It
Yeah,
has. It really has actually been sort of forever.
It is. It's really nice to see you, though, and to talk to you. Thanks for taking the time to be on the podcast with me today.
I love being on this side of the mic. Actually, it's scaring the hell out of me. But
yeah, you're usually in control when it comes to the podcast conversation. So
right. Well, what I like in the podcast conversation as a podcaster is I talk for 30 seconds and then the guest talks for 3 minutes. And
right
now it's sort of reversed a bit.
Yeah. So hopefully you still have something to say, but I bet you do because you're a smart guy. And you proposed a really interesting and important topic for our conversation today, which is unit testing. Maybe not even the sexiest topic. I know, this maybe like 10, 15 years ago was like the big thing on people's radar at conferences. There was a lot of talks about it, but it's such an important thing. And, we're both professional developers and consultants, and we know from looking at all the code that we touch every day that's out there that there's a lot of projects that still don't have unit testing at all.
Right.
So it's an important topic. But just to start us out, I thought you could kind of give, if it's kind of a new topic to somebody, you could give maybe the lay of the land. How does unit testing differ from the 12 different other kinds of testing that exist out there?
Sure. I should say that one topic that we won't get to, but just to put a footnote, is unit testing and why don't we do it, which is a whole other show. But unit testing is, as the name implies, testing the smallest unit of your application, typically a method, as opposed to integration testing, where you're looking to see do different parts fit together, or end-to-end testing, where you're looking to see if the whole application works, or UI testing, where you're looking to see if the user interface is. So there's a lot of different kinds of testing. Right. In my mind, unit testing is I have this method, typically, choose your unit, but a small unit of work, and I want to make sure that A, it does what it's supposed to, and B, when I throw something unexpected at it, it handles it gracefully. So I'm looking to see, okay, this method is supposed to add 2 numbers. Does it give me the correct result? Okay, great. What happens if I give it a 0? What happens if I give it a negative number? What happens if I give it a letter? What happens if I leave one of the numbers out? So there's a whole lot of things you can do with it, with a simple method, to just make sure that when that thing that you don't expect but will inevitably come along, that you have prepared for it and that you're going to survive it.
So unlike some other kinds of testing, which is kind of one time, if you will, if you're doing just traditional functional testing or integration test or end-to-end test or something, you're kind of checking to see, does the application or does this feature or this screen or whatever work right now, is basically what your question you're asking, right?
But, right. And there's a key reason for that. I mean, I was being a little superficial, but the key reason in my mind for unit tests is that, let's say you have a section of your code that's working, and now you're going to either refactor or add another section. it's very troublesome when I do something over here and it breaks over there. It's a very
Right.
hard bug to find. And unit tests can help a lot in identifying that right away.
Mm-hmm.
But for that to work, you have to run them all the time. And for
Mm-hmm.
that to work, they have to be really fast. So there's a synergy there, if you'll pardon the expression, in that you want really fast unit tests that you run after, virtually after every change. And
Mm-hmm.
and that says, okay, it's still working. I haven't broken
Yeah.
anything.
Right. So it's important, I think, to think about unit tests as something that you rerun, not just something that you run, right? That they're
Yes, yes.
constantly being rerun. And we've got this term in the industry called shift left, right? Which says the earlier you do this stuff in your process, or for most of us that read left to right, shifting left in your process, right? Now, why is that an advantage in this case for unit tests to shift it to the left in your process or earlier in the process?
Well, a truism in the industry going back 30, 40 years is that the earlier you catch a bug, the less expensive it is to fix,
Mm-hmm.
for any number of reasons. The worst case is that you don't catch the bug until a customer calls you up and tells you about it. The best case is you catch the bug the instant you put it in, because
Mm-hmm.
then you know exactly what you did. You don't have to go hunt
Right.
for it, and you know what it broke. And unit
Yep.
tests are the vehicle for doing that.
So the best place for a developer to find a bug is as they're typing it. But the second
Yes.
best is maybe a unit test that runs after they save the file or something, right?
Right, right. And there used to be an expression, vote early and vote often, and I'm a big believer in save early and save often. And
Uh
I
huh.
even these days believe in check in early and check in often. But that's a whole other
Definitely.
conversation.
You never know when you're gonna spill coffee on your laptop or something, right?
That's right. That's exactly right. I think one of the issues that comes up with unit testing is when you write the unit test. And there are basically two styles. There is what
Mm,
the vast majority of people do, which is test after development. So you write a little code and then you test. The other is test driven development, which is almost a different science. I mean, you're still building unit tests, but with test driven development, you're saying, okay, what do I want to accomplish? Now let me write a test that would be true if I had accomplished this before I write any
yeah.
code. And make sure that test fails, of course, because you haven't written the code.
Mm-hmm.
Then write it and see if you can make it pass. And there's all sorts of advantages to doing that, but it's hard to get your head around. And I know an awful lot of us think test driven development is a great idea and don't do it. So
I think the name is a bit confusing too. Test driven development. I always think of it as test first development.
mhm.
Is that? Do you think that's an accurate way to think about it?
Well, the reason I think it's called driven is because once you have the test,
Mm-hmm.
then your design and your code is
Conforms.
forced into
Mm-hmm.
making that test work, which can be a very
Mm-hmm.
good thing. But
Mm-hmm.
it's the test that's driving what code you actually write at that moment.
Mm-hmm. So we talk with unit tests. We talk about that them as creating something called code coverage. Can
Mhm.
you give kind of a high level definition of what that code coverage means with unit
Sure, you
tests?
want to make sure that that you're covering with unit tests as much of your code. I hate to use those words because I'm just repeating the words. You want to make sure that
Right.
that you're testing everything, that you're
Yeah.
and not just the main line through your code, but as I said before, all the corner cases, all the
Right.
exceptional cases.
So,
Um,
so if you have all these nested if else statements or whatever in your method, yeah. Well, the first of all, yeah, please rewrite it. But
right,
sometimes you have some complex logic, and you want your unit tests to go through all of those, right? Not just
hmm right.
one
Go down every
happy
path.
path. Hmm.
Exactly. Go down all the happy paths. Go down all the sad paths, and anticipate as much as possible. But the main, yes, you want to do all of what I just said in terms of
Hmm.
quality, but and you want there are tools that can tell you, do you have sufficient code coverage? Have you tested everything in your
Yeah.
program, or what's missing? But the key, I keep, excuse me, I keep coming back to is as I'm writing or as I'm refactoring, especially when I'm refactoring, have I broken anything? Because if I
Mm-hmm.
know if my tests are working properly and I have sufficient coverage, that I can change my code with confidence.
Mm-hmm. So there's some magic numbers out there in the industry that say this is the number you quote unquote should have of code coverage in your project. Do you have a way of thinking about that? When do you have enough versus when are you maybe going into that diminishing returns area?
Right. I wish I could give you my magic number. I wish I was that good. Um, it's not 100%.
Right.
It's not zero.
So somewhere in that range.
It's in the middle.
It's
It's
one
on
to
the high
ninety
end.
nine.
It's on the high
Yeah.
end. I mean, is it
Yeah.
80%? Is it? What's your magic
Hmm.
number?
Yeah, that's a great question. I don't think I have a magic number. I feel like there's different needs for different projects. Um,
I think that's right.
so let's take an example of maybe you can give me an example that you've seen where a unit test was written for something that felt silly or like overkill, without any names.
Right,
um,
right. You see some unit tests that test that um, a simple operation that can't fail.
right.
It's so simple that it's
Mm-hmm.
almost defining itself, that the test
Mm-hmm.
becomes. I don't want to overstate this because there are things that look like they can't fail and then do. There are
And
a
do
lot of
right.
things that look like they can't fail, and then you
Sure.
stare at them and you say, "That can't
That's right.
happen."
At
There's a
first blush, dividing a number by another number seems pretty safe, and then
yeah,
what
unless the
happens if
number's
it's the second
zero,
one's
right?
zero? Yeah.
Right. I have a mug in which this programmer is staring at something saying, "Why doesn't that work?" And then below it, he's staring and saying, "Why does that work?" So it's a
Yeah.
lot like that.
Yeah.
Um, I think that anytime, well, I work a lot in mobile, let's say that.
Mm,
And in mobile, a lot of what you're doing is in the user interface. And it's very
mhm,
hard to write unit tests. You write UI tests for that. But
mhm.
there is logic, and that logic needs to be tested. And
Yep.
so if you're doing a paradigm like MVVM, model view, view model, virtually everything in
Mhm.
the view model should be tested.
Right.
And I think that there are other, model view controller, there are a lot of different paradigms depending on what world you're working in. But there's always
Mhm.
a place where the logic, hopefully, there's a place where the logic is isolated and centralized as opposed to just being entangled. And then you have an opportunity to go in and test that. And we could talk about some of the techniques and dependency injection and all of that. But the
Yeah.
bottom line is need to be able to get at that logic and test it.
Let's come back to that because I do want to ask you about that. But just to kind of finish up this point, so as an example of something that I've seen that didn't make a lot of sense for unit testing is it was actually an ASP.NET MVC application that was testing whether the right controller was selected for different routes, which essentially was, for those that are maybe not familiar with that framework, that was basically testing the code that Microsoft wrote and
Right.
presumably also had unit tests for. And that all,
Right.
struck me as a bit silly and overkill. Like you don't need to retest that Microsoft's framework is working.
That's a great
Hopefully,
example.
yeah,
Yeah. With 10 million people are testing it for you, then you may not have to test it.
exactly, exactly. Okay, so coming back to your earlier point, though, there's some other technologies or approaches or whatever you want to call them that are tangential to unit testing. You mentioned dependency injection. I think you might have mentioned mocking a bit
Mhm.
earlier as well. Can you talk a little bit about those and any others that might
Sure.
come up in this conversation?
Sure. All of them. Yes, sure. Um, the, if you're going to build meaningful unit tests, then you quickly confront the problem of there are outside resources that your code needs to talk to. So it needs to talk to a database, or it needs to talk over the net, or
Hmm.
it needs to talk to an API. And remember that we said that unit tests have to be super fast, and those things tend to be super slow.
Yep.
And in order to make the unit test run as quickly as it needs to, you have to solve that problem. And the way you solve that problem is using what's called a mock. And a mock says, I'm going to stand in for whatever it is. Let's say it's an API out on the network. And I'm going to give you a response instantly. And not only am I going to give you a response instantly, but I'm going to give you a perfectly predictable response. Every time you
Mm-hmm.
ask me, I'm going to give you the same response. So you can test. You don't have that uncertainty of was this the right result or not. There are a lot of mocking frameworks. You don't have to write your own. A very popular one is MockQ, MOQ. The one that I've started using recently is NSubstitute. I really like a lot. But basically, what you do is you create a mock instance, and then you tell it, when I call this, give me back that.
Mm-hmm.
Now you need to get that into your, so that it can interact with your method. In order to do that, you need to be able to use what's called dependency injection. And the way that works, and I almost always use constructor dependency injection, so I'll just focus on that, is that in the constructor, when you're passing in an object, instead of passing in an object, you pass in an interface. And you can then pass in the actual interface when the program's running, or you can pass in the mock, which will act on that same interface, will be an implementation of that same interface, and therefore will be accepted by your program. And that allows the test to reach in and interact with the code that's in your method. Then, if you're going to do dependency injection, there are tools that are related to dependency injection, such as inversion of control containers, which took me a while to get my head around. And the idea of an inversion of control container is actually a very, very cool thing, which is
Mm-hmm.
rather than making an instance of something and passing it to a method, you tell your inversion of control container, when I ask for one of these objects, give me one. Here's
Mm-hmm.
how you make it and give me one. And then
Yep.
in your code, you never use the word new. You never say what we used to call newing up an object. You never
Mm-hmm.
say car equals new car. Instead, you
Mm-hmm.
just pass an iCar into the method, and the inversion of control container says, oh, he needs an iCar. I know what that is, and passes it
Yeah.
in. And he says, and by the way, that iCar object is dependent on having tire objects, and I'll make some of those for him. So the
Yep.
inversion control container makes your code uh, independent of passing in those objects. You can use interfaces, and that allows you to use mocks.
Once heard the phrase "new is glue," basically saying, anytime you use that new keyword, run the constructor, you're kind of gluing that dependency to your
Right,
class.
right. And what goes with that is the whole idea of decoupling. The more we can decouple the code and make things more independent, then the less likely it is that if I change this, that'll break.
There's lots of advantages to that decoupling, but one of them is that makes unit testing easier because it makes mocking easier, right?
Mm-hmm. There's all
Okay,
sorts of
so
good reasons.
yeah, there's lots of great reasons for it. Um, so this brings up the next topic though, which is that's all well and good when you're creating a greenfield project, but what about brownfield, right? When
Yes.
you've got none of those things in your code base and you want to start unit testing. So now what do you do? Not
Now,
start unit
Robert,
testing?
yeah, it's a problem.
It is.
Robert Martin has a really good book on this about what do you do in exactly that situation. And what he suggests, and has worked to some degree for me, is that you carve out a very, very small part and figure out how can I decouple it from the rest, and
Mm-hmm.
then how can I test that one very small part, as opposed to trying to
Mm-hmm.
put unit tests everywhere. And then
Right.
you sort of grow that from the inside out. But we're also all under time pressure, and it's hard enough in a greenfield project to convince whoever you're working for that it's worth taking the time to do the unit tests. In a brownfield project, it takes longer to make those unit tests. And so the return on investment is not as high, and add to the fact that, hey, it already works. Why do I need to test it?
Mm-hmm.
Like, it's been out there for 3 years. It's been working. Why are you adding unit tests?
Right.
So
Yeah,
that,
yeah,
yeah, it's
exactly.
a tough one.
It's hard to make that argument sometimes to a boss or to a business owner of a product. This product that's working fine, we want to unit test it, and it's to make it more reliable in the future. And that seems like just a like gold plating type of an exercise, right?
Right. You could argue if you have a brownfield project that you're not going to change. You're not going to add any
Mm-hmm.
features, and you're not going to in any way change the interaction, increase the number of people who
Mm-hmm.
are using it.
Right.
I hate to tell you your project's dead, but assuming you're in that situation, you could probably convince me that end-to-end testing would be sufficient for a while, but
Yeah.
that situation doesn't exist.
Yeah. Yep. That's true. Yeah. Live software that's still being used is probably going to be maintained or changed, or the framework needs to be updated at some
That's
point.
why it doesn't exist,
Right.
because even if you don't
Yeah.
make any changes, at some point the thing you built it on becomes obsolete, and you're going to
Mm-hmm.
want to upgrade to the next version of the operating system or the framework or something, and then all sorts
Mm-hmm.
of things are going to break.
Right. And you won't know what they are without doing like a full regression
Right.
test, right?
Right, exactly. And things that appear to have broken, actually, that's not where the break is. That's where you're seeing the break, but the break is earlier in the pipeline, and you won't know that because you don't have unit tests telling you so.
Yeah. Okay, so you touched on this, but I feel like there's two different types of resistance to unit testing. One of them is from the engineers. That could be like, the way I'm doing it works, or my code doesn't need that, or that's overkill. Those types of arguments that are basically all boil down to I'm too good to require that. And then there's the boss types
Uh-huh.
of feedback that you get that is like, how long is that going to take, and why are we doing this? So, any tips for somebody listening to this that's facing one or the other of those types of resistance, and
I
how
don't have a
to
lot of
address
patience
those?
for the first one. People who think they're too good to make errors worry me.
Yeah, yeah.
Um, so in my experience, that's mostly junior programmers, and they
Mhm.
can be mentored out of that,
Sure.
or they can be escorted out of that. But uh, the problem with management saying no, we don't have time for that, or what I run into more is, yes, that's an excellent idea, but we need this thing delivered by Friday,
Right.
which makes it unrealistic. That
Hmm.
is a significant problem because you're trying to balance a long-term return against a short-term need, and the short
Something
term is,
humans are not great at.
yes, exactly, exactly. Especially when there's financing involved,
Right.
right? So there's
Yep.
always pressure for quick return,
Hmm.
and unit tests are not really about quick return. They're
Hmm.
about not screwing up the long return.
Right. Okay. So along those lines, when you think about, say, estimating tasks, which happens in a lot of projects, you and I have both been consultants quite a bit in the
Yep.
past, and currently. And obviously, when you're a consultant, your time is your product. So estimating and then tracking that time against that estimate is necessary. A lot of teams that are even doing internal development will be tracking that, though. So when you think about unit testing, do you think about it as a separate task, or do you think about it as part of the development task?
I think about it as part of the development task, but when I'm giving an estimate on time,
Hmm.
I tend to think about how long will it take to develop this, and then add 30%,
Okay.
roughly.
So
There are
that
people who argue
30%.
50%, but I tend to think, okay, about a third again
Hmm.
for building the unit tests and doing the testing and so on.
So how you communicate that, if you have maybe a resistant boss, it's better to communicate that all rolled into the task. This is just how long it
Right,
takes to
but
do the task well.
there's also pressure to give a lower estimate, right? Because nobody wants your boss to say, "What? Why is it going to take so long?"
Right.
Uh, on the other hand, underestimating is deadly because you won't hit it, and then that's
Right.
worse. So my general approach is figure out how long it's likely to take, add time for unit testing, and then add some wiggle room. And the response to why is it going to take so long is because you'll notice that for the past year I've been getting everything in on time.
Right.
I don't have a better
Yeah.
answer than that one.
Yeah. No, that's a good one. All right. You're a .NET guy like me. So where do you fall on the eternal .NET debate of MS Test versus NUnit versus XUnit?
Yeah, I tend to use XUnit. Um, the people who did NUnit were involved in building XUnit and made some don't ask me what nice changes. I used to remember the things they did differently. Um, some of their guidance changed about where setup and teardown should be in XUnit, although I don't think it's enforced anymore. MS Test has never impressed me as particularly easy to use. XUnit feels easier to use, and Microsoft now has the test runner in Visual Studio working really, really well with it. So by default, I guess I use XUnit. It
Yep.
also works really well with all the mocking frameworks I've tried.
Yeah. Yeah. The nice thing is that we're not talking about 10, 15 years ago when the not invented here thing was a problem at Microsoft. So
Right,
all
right.
this stuff is supported in the tooling, and that's great.
Yeah, Microsoft has really turned that around, and I think part of the open sourcing of Visual Studio and has made a huge difference in terms of
Yeah,
internal attitude about interacting with other tools.
for sure. Um, so let's say you've been listening to this conversation and you want to get started with it, learning more about unit testing. We've maybe finally convinced some people listening to really go for it. Um, you mentioned Bob Martin's book for Brownfield projects. What other resources do you recommend for getting started?
Well, if it's a greenfield project, there are a number of good dedicated books. There's also, Microsoft Learn has become
Hmm.
infinitely better than documentation was for a long time, and there's a lot there. I
Mm-hmm.
might start there. Since I write books, I'm hoping you'll also buy a book on it. I don't have any on unit testing. I don't think. and Um, the other, well, everybody should start absolutely with, again, Robert Martin's Clean Code. I would start there with
Mm,
that book. Um, that for any number of reasons, not just unit testing. I'm a big fan of him and of that book.
mm.
Uh,
Speaking of books, by the way, you just had a new book, not about unit testing, but a new book that the people should know about, and also co-written by a Trailhead team member along with you. So, can you tell us a little about that?
you're so nice to let me plug my book. It's called .NET MAUI for C# developers. And can you hear that? That's my dog. I
Yes,
don't know if you can hear
that's
that.
yep.
Uh, It's called .NET MAUI for C# developers,
Hmm.
and it's from Packet, or they taught me to say Pact, and I'll
Mm,
learn that one day. And it's designed for people who are not mobile programmers, not necessarily MAUI programmers. We did put in a
yep.
chapter on unit testing because that is extremely important, and part of, I believe, learning any framework is learning how to do unit testing with it.
Mm,
And it
great.
just came out. Oh my
Yes,
God!
and I am looking forward to reading it very soon.
I'm so
Thanks
sorry.
for no, that's okay. So, last question, Jesse. We like to ask everybody on the podcast this because, we got to come up with ideas for new podcasts. So we're kind of cheating by asking you to do our work for us. But we talked about unit testing today. What other topics or people should we be talking to about making software projects more predictably successful?
Well, how much have you talked about Scrum and other forms of, help me with the term,
Agile?
uh, agile? Thank you. Agile
Yeah.
development. That's a
Um,
huge topic and super
yeah.
important.
Yeah.
So
That's
that's
a
one
really good
possibility.
one. Hmm.
And
We've
in terms
definitely
of
touched
people,
on it, but that's a good one.
yeah, it's become more and more important in my life.
Mm,
I really find there's a huge difference in the likely success of a project if it's done through agile principles and not just Oh, we sort of use Agile, but
Yeah.
to be fairly rigorous in your use of Agile,
Yeah.
I think makes a big difference. And I'll
Hmm.
mention two names to you. First of all, you probably could get Robert Martin. He was on my podcast, and who knows if he is available. But he was on yet another podcast, which is mine. And I think I've come to hate that name. And also, a great person to talk to about your topic is Sean Wildemuth. I don't know if you've had him,
Mm.
or you probably
No,
know
not
him
yet.
well,
I do,
uh,
sure, of course. Yeah. Love to
but he
have
would be a
either
great
of those
person to have.
guys. Yeah. Very good suggestions. Thank you also for your knowledge and sharing that with us about unit testing. I really enjoyed this conversation and appreciate your time, Jesse.
Well,
Thanks so much for
thank you
joining
for
us.
having me and my dog on your podcast. I appreciate it.
We'll have you both back sometime
That'll be great.
very soon. All right. Thanks, Jesse. That's the end of This Blue Blazes podcast. If you're interested in hearing more conversations like this one, with industry experts focused on how to make software projects more predictably successful, make sure to subscribe. Trailhead can be found online at trailheadtechnology.com, on Twitter, LinkedIn, and Facebook. Until next time, thanks for listening.